Hello world, and thank you so much for tuning in. Today I am going to be demonstrating a program that I wrote in Python called Cyber War. So here's your problem. You want to play a game, but you don't have anyone to play with. Well, this is your solution. Just play with yourself, because this is a card game for one. But first, let me tell you a little bit more about myself. My name is Sarah, and you can find me on Twitter and Facebook at Just Sayin' Page. I live here in Tucson, Arizona, and I started teaching myself Python about 2 years ago. I am definitely a lot farther down the road from when I first started, but I have a lot to learn, and I'm definitely looking forward to growing as a programmer. I recently participated in Code in Place 2021. It's a free online course offered through Stanford University, and it teaches the fundamentals of programming in Python. This is part of my final project. If you want to check out everybody else's work, you can go to codeinplace.stanford.edu/2021/showcase. Okay, so I'll start off by going over the rules of Cyber War, which are the same as the classic card game War. Here's the deal. A shuffled deck of playing cards is divided evenly between AI, the computer, and player 1, the user. Each player starts the game with 26 cards. At the beginning of the game, each player reveals the top card of their deck at the same time. The player with the higher card wins both cards and places them at the end of their deck. Okay, so Cyber War happens if both players reveal cards of the same value. If that happens, each player puts a card face down on top of the tied card and then one face up. Whoever has the higher face up card takes all 6 cards. And if players reveal cards of the same value again, it's another round of Cyber War. The game ends when one player has won all the cards. Okay, so let's dive in. The main program is one function called Cyber War. What is Cyber War? Let's take a closer look. Okay, so there's several steps. Step 1, define a standard deck of cards as a list. Okay, so I named that deck of cards. Step 2, assign numerical values to each card in the list using a dictionary. Named that card values. Step 3, shuffle the deck of cards using random. Step 4, define AI's cards as the first 26 cards in the now shuffled deck. And step 5, define player 1's cards as the last 26 cards in the shuffled deck. Okay, step 6, start the game. Let's take a closer look at the code here. You'll see the round is equal to 0 because nothing has happened as of yet, while the length of AI's deck and the length of player 1's deck is not equal to 0, the user is going to be prompted to press enter to start the round. That's when the round will start to be counted. A card is going to be popped out of AI's deck, and then it's going to be assigned a value. The same thing will happen for player 1. A card will pop from player 1's deck, and it's going to be assigned a value. After those lines of code are ran, you're going to see on screen AI card, and then whatever card popped for AI from AI's deck, and then it's going to show your card, and it's going to show whatever card popped from player one's deck. Okay, so once AI's card and player one's card are determined, the next step would be to compare the cards to see who wins. There are three possibilities. The first possibility is AI has a higher card and wins. If that's the case, it will print AI won this round, and then two cards, AI's card that they just played, plus player one's card that they just played, will be appended to AI's deck. Then it will print AI now has X number of cards, you have X number of cards. Then the user will be prompted to press enter again to start the next round. The second possibility is player one has a higher card value and player one wins. If that's the case, something very similar happens. It prints out you won this round. The two cards that were just played, player one's card and AI's card, are then appended to player one's deck, and then it prints you now have X number of cards. AI now has X number of cards, and again the user is prompted to press enter to start the next round. Okay, so now we're at possibility number 3. This is where it gets interesting. This is cyber war. So the code starts out by creating an empty list named winner's pot, and then I'm going to start counting the rounds of war. So we have war round equals 1. This is going to happen when the AI card value and player one card value are equal. It's going to print cyber war round and then have the round number. Okay, so if this is the first round of war, cyber war, this is where things get interesting because the code can go a number of different ways, and it's based on the length of both the AI deck and the length of player one's deck. For example, if the length of the AI deck is 0, they don't have any more cards to play. So they just played a card. This is, let's say, their last card, and they put it down, and player one is showing the same value card. They can't move forward, you know, into a round of cyber war because they don't have any cards left. So what happens in that case is their quote-unquote war card is just the card that they just played. So they just have to lay that down and hope for the best. If AI has one card left in their deck, then they can't whip out more than that one. So this is the code. It's going to just pop out that last card that they have, and then their war cards will be their original card that they just played that caused the cyber war to happen, and then that last card that they have in their deck. Finally, and probably most commonly throughout the game, if the length of AI's deck is at least 2 or more, then what's going to happen is they're going to have a total of 3 quote-unquote war cards. The first card will be the original card they played that prompted the cyber war to begin with. A second card that is not seen unless you're looking at the code, and then it's not, by not seen I mean it's not revealed to either player, and then another card that is called War Card 2, and War Card 2 is the card that is then compared to player 1's War card, if that makes sense. And then it's pretty much the same scenario for player one, depending on if they have 0 cards left in their deck. If they have 0 cards left in their deck, they can't pull out any more cards to play Cyber War with, so they just have to rely on that 1 card that they just played. If player 1 has 1 card left in their deck, then they'll have 2 war cards. The original card that they just played that prompted the Cyber War, and then that last card in their deck that is placed face up. And finally, if player 1 has at least 2 or more cards left in their deck, same thing happens as I just explained. They have the 3 total war cards that are going to be at stake. They have the original card that they flipped that prompted the Cyber War, a second card that is kept face down, and then a third card that is flipped that is the one that is compared to AI's flipped card that determines who wins the battle. Okay, so regardless of how many quote-unquote war cards AI or player one had when they're facing each other in Cyber War, all of those cards are put into that empty list winner's pot. So the next part of the code is going to print the winner's pot now has X number of cards. So that basically just states how many cards are at stake in that particular round of Cyber War. And then again, there's 3 options. Option 1 is AI's card is higher and AI wins. Option 2, player 1's card has a higher value and player 1 wins. In either case, you're going to see that whether AI wins or player 1 wins, whoever the winner is, the list of cards that are in the winner's pot is then added to the winner's deck. Okay, so this is where things get very interesting. If after a round of Cyber War, the AI card value and the player 1 card value is the same again, then it basically just goes through another round of Cyber War, and that cycle will continue, although doesn't happen very often, will continue until, you know, either one player runs out of cards or someone gets a higher value card. Okay, so there's very slightly different coding if the game moves into a second round of Cyber War. The main difference is obviously someone has to have at least 1 card to move forward into a second round of Cyber War. So the main difference is in the coding is the length, if the length of the deck equals 1, 2, or 3 or more. And then the same thing happens at the end of a round of Cyber War. All of these cards, as Cyber War continues through the rounds, if there's more than 1 round of Cyber War, all of those war cards are saved into a pot called the winner's pot. And it will continue to print. The winner's pot now has X number of cards. If AI wins, then the winner's pot is added to AI's deck, and the same goes for player one. If player one wins, then the cards in the winner's pot is added on to the end of player one's deck. And then either case, it's going to print how many cards AI has in their deck and how many cards player one has in their deck. Okay, and this process will continue. Rounds of Cyber War repeat until a player plays a higher card or a player runs out of cards. When does it end? The game ends when one player has won all 52 cards. And that's what that looks like. So if the length of the AI deck is 52, it's going to print game over after X number of rounds. So it actually keeps track of the number of rounds that you play back and forth. It'll say X game over after X number of rounds. Either AI won the Cyber War or you won the Cyber War. Let's play. Okay, so as you can see, I'm just pressing enter, and the game just kind of keeps track of what's going on here. You can press, it was like almost like pressing fast forward here. Now, what does it look like if we fast forward? Okay, in that case, what I do is I just put a hashtag in to make where it says input, press enter to start round. I just put the hashtag in, and that's going to make it a comment. And then I don't have to press enter. All I do is type in the program, and it'll go through the entire thing quickly. And as you can see, game over after 108 rounds. You won the Cyber War. You could do it again. Okay, in this case, game over after 185 rounds. You won the Cyber War. Again, go you. Third time's a charm. Okay, game over after 1,095 rounds. You won the Cyber War again. So, that's it. Thanks for watching, and if you have any questions, yeah, let me know.